So now we'll be starting with direction sense test, which is our new chapter. I find the name very interesting for some reason, direction sense test. So yeah, I find it a very interesting name. Anyway, let's just begin. We'll first see what are the main theory that you need to solve questions that come under direction sense test. And also we'll also do some questions. Okay, so the first thing that okay, what do we mean by the first basic thing, right? What do we mean when we say direction sense test? Basically, it's when you have questions under this topic, it's about regarding the movement of a person or an object from a starting point up to an end point is basically what we do here. You look at the movement from a starting point, which is usually called an origin, up to an end point. Okay, this is what we mean by direction sense test. And you have four main cardinal directions, that is east, west, south and north. Okay, these are our four main cardinal directions: east, west, north and south. All right, so now moving ahead, another important theory that you need here is how to find the shortest distance. Okay, this is an important theory that you need when you do questions of that come under cardinal directions. Okay, oh, I'm sorry. Okay, so basically, how do you find the shortest distance? What is the formula for it? Right, it's basically something called the Pythagoras theorem. I think you guys would have already studied the Pythagoras theorem. So I'll just take you through a recap of the same. Basically, why do you use the Pythagoras theorem? To find the shortest distance between 2 points. Okay, now in the Pythagoras theorem, what it says is that if you have 2 points, okay, and if you can make a triangle between the 2 points, okay, take a third point. Okay, so here let's say you need to find the distance between A and C. You get a triangle using B. Here, if you know the distance of between AB, that's this distance, and BC, then you can find the shortest distance between A and C. And the shortest distance between A and C, to find the shortest distance will be this distance. Okay, that is this hypotenuse. The triangle has to be a right angle triangle. Okay, so you take a right angle triangle and then the hypotenuse jo hai, this distance is going to be the shortest distance. How do you get this distance? By using this formula: c square equals a square plus b square. This is the formula to get the shortest distance. Okay, the shortest distance between A and B can be found using this formula. So when Pythagoras theorem, in that he just said, that you have a right angle triangle, the square of the hypotenuse is equal to the square of the two legs. That's all that he said. But we use it to also find the shortest distance. Okay, moving on. Now we have a very nice, interesting example question that we will be dealing with. Kavya walks northward up to 10 meter. She then turns left and walks 30 meter. She turns left again and walks 50 meter. At what distance is Kavya now from her starting position? I'll just give you a moment for you to just read and sort of digest this question. Just read it and try to maybe write it down, in a figure and stuff like that. Just see what do you mean by this question. Just give you a moment. Okay, so basically what we mean here is that we start with, let's give Kavya a position here. Kavya walks northward up to 10 meter, right? So okay, we'll just draw this main directions: north, south, east, west. These are the directions that I told you about here: north, south, east, west. Okay, so Kavya goes 10 meter northwards. She then turns left. So Kavya is here. Where is the left of Kavya? It's going to be, okay, the left of Kavya is going to be here. She turns left and walks 30 meters. You draw a longer line for 30, okay, because here 10 is represented using this line, right? So for 30, draw a longer line. Okay, so now she's here. She turns left again. So, okay, now this is a part where you need to be clear. So for a person standing here, where will that person's left be? So basically here it's almost like, standing like this. Where's my left? My left is here. So it's going to be in this direction. Now, how do you find this out? What do you do if it's difficult? So one easy way to look at it is just think of where the person is facing. So the person started here and the person started at this point, and the person is sort of, like, I'll just show it in a sort of like a 3D setting. So the person was walking here and the person walked like this. Right now, where is the person facing? The person is standing here. The person is facing this direction, right? So this is basically the direction that the person is facing. Now, keep the direction the person is facing as north. Okay? If you keep this as north, then you know that the east comes here and west comes here. Keep east as right and west as left. So now you know that the left of the person is here. Okay, so that's a good way of figuring things out. Or another thing you can do is just think yourself in the shoes of that person. Like, think, okay, I'm standing here, I'm facing this direction, so my right is here, my left is here, so this is my left. Okay, that's another way, but drawing this compass also helps. So anyway, she turns left and she walks 50 meters. So draw an even longer line because it's 50 meters. This Kavya has done a lot of walking. Now, at what distance is Kavya from her starting position? Okay, so I need to find at what distance Kavya is. This was her starting position. This is where she is now. How do I find her distance from the starting position? So here, when we ask for distance, what we mean essentially is the shortest distance, right? Because when you say distance, like if somebody asks you the distance between your home and some places, there might be a longer route, but you won't say the longer distance, right? Unless that person is your enemy. I mean, then you might, I don't know, but ideally you tell them the shortest distance, right? So here we need to find the shortest distance between this Kavya and this Kavya. Basically, Kavya's initial position and Kavya's final position. So this is basically the distance that there is. The shortest distance, like we studied earlier, is if you can make a right angle triangle, you're done. So here I can draw a right angle triangle like this, right? Okay, so now, but do I know these distances? You will find out that yes, I do. So do I know this distance? Yes. How do I know? Because see, I know this distance, right? This distance and this distance will be the same because we're talking about two points in the same line. So basically, like, I will draw it here. See, you have 2 points from the same line, okay? If these are two parallel lines, the distance here and the distance here will be the same, right? So basically, if I keep my hand like this, distance between these 2 points of my hand and these 2 points of my hand will be the same because these are parallel lines. Okay, because here the width is the same and here the width is the same. Okay, so similarly here, since these are straight lines, there is no curve. Like for example, if it's something like this and this, then it's not the same. This distance and this distance is not the same. But if these are two straight lines, then this is the same. Straight lines as in if they are parallel. I mean, see, if it's something like this also, it's not the same. These distances are not the same, right? But if it's like parallel, so we drew it as parallel lines, right? So you can know that this distance is the same as this distance. So if this is 30 meters here, here also it will be 30 meters, okay? It's going to be 30 meters. So now, do we have this distance? Again, you find out that to our surprise, yes, we do. How? So I'll shift to a different card. We have this overall distance, right? This overall distance, as we know it, is 50 meters. Okay. From this 50 meter, I need to reduce this part. I don't want this part. Okay, this is what I need to reduce. How do I reduce this part? Just give me a second. Right, so this is the part that I need to reduce. Okay. How do I reduce this part? I need to cut this part. How do you cut this part? Again, like we talked about the parallel distance concept earlier, this line distance is same as this distance. And this distance we know is 10 meters. This is what Kavya walked first. Okay. So this distance is the same as this distance, which is 10 meters. So you know that this is 10 meters. So from 50 meters, if you cut 10 meters, what do you get? 50 minus 10 is 40. So you know that this distance is 40 meter, and we got that this distance is 30 meter. Now we can find this. Okay, so I hope the concept is clear. Basically, it's just that, you know, when you have two parallel lines, this distance will be same as this. Similarly, this distance will also be same as this. You would have learned the parallel line concept before, right? So anyway, we have a hypotenuse triangle, two legs, 40 meter, 30 meter. We need to find the hypotenuse. What did Pythagoras say? Basically, this distance, if you take C, A, B, I'll go back. I think, you know, yellow, this yellowish color might not be a comfortable color for everybody, right? So here, you know that C square is equal to A square plus B square is what Pythagoras said. Okay, so here, C, what is your hypotenuse? We don't know this yet, but it's equal to A square plus B square. What is A square? If you take A as 40, A square will be 40 square, B square will be, B is 30, so you get 30 square here. What is 40 square plus 30 square? Basically, what is 40 square? 40 into 40. What is 40 into 40? 1600, right? 0, 0, 4 versus 16. 1600, that is 1600 plus what is 30 square? 30 into 30, 900. 1600 plus 900. What is 16 plus 9? 25, and it is 2500. So you get that the answer is not 2500. The only thing that you have here is this. Okay, you know that C square is 2500, but what is C? C is the root. So see, if C square is 2500, C is going to be the root of 2500. What is the root of 2500? What is the root of 25? 5. For double zeros, to find the root, you just get 1 0. That's how you, I'm not sure if you guys have learned this before, but I'm sorry, right? So basically, how do you, right, so to find the root, if you have two zeros, you take 1 0. So like basically the root of 100, those two zeros you reduce to 1 0 and you get a 10. The root of 1600, you find the root of 16, that's 4. Both of these 0 make it 1 0, it's 40. So similarly, for 2500, find the root of 25, it is 5. Both zeros make it 1 0, it's 50. If you don't believe me, you can try multiplying. 50 into 50 is 2500. So anyway, the answer is 50 here, and you get this. You've gotten the answer, okay? So at what distance is Kavya now from her starting position? She is at 50 meters. 50 meters is her distance from her starting position, okay? That's it. Moving on. Now the next concept that you need for direction sense test questions is angle of movement. Okay, for solving questions that pertain to angle of movement, you need knowledge of clockwise and anti-clockwise movements. Okay, this is something that I've already explained in one of our, I think in clock and calendar we explained this, but I'll just briefly take you through it again. Okay, so clockwise is basically the movement that is of this sort. Okay, the arrow faces like this, basically go like this. And anti-clockwise is the direct opposite. You just go like this. You go like this instead. So I mean, a good way to remember it is, you know, when you if you have a bottle, if you try to tighten the bottle, so this sort of works, but yeah, just try taking a bottle or something and try to tighten it. When you tighten it, the direction in which you go is clockwise. When you open it, the direction in which you go, for most bottles, okay, the direction in which you go is anti-clockwise. Now, what is a very easy way to remember this? Just think of how the clock works, okay? So let's imagine that this is a clock, okay, 12, 3, 6, 9. How does a clock work? If let's start it at 12, okay? Now, how does this minute hand go? After 12, does it go here? No, the minute hand goes here, right? It goes here, and then here, and then here, and then here, and then here, and blah, 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 blah. This is how the minute hand goes. So this direction in which the minute hand goes, basically like this, okay? This is called clockwise. So this direction is called clockwise, and the opposite to that. So the minute hand goes like this. The opposite to this direction is anti-clockwise, okay? That is this. The opposite to this is called anti-clockwise. This is how you know. So you can either, there are different things you can look at. You can either look at how your clock works, or you can look at how you close and open a bottle, different things. Okay, so this is just the concept you need to know. You just need to be thorough with what it means to be clockwise and what it means to be anti-clockwise. Okay, it's a concept that we have also studied under clock and calendar. So yeah, it's what we are doing now is basically like a revision. Okay, moving on. So let's do a question under angle of movement. A clock is so placed that at 12 noon its minute hand points towards northeast. In which direction does its hour hand point at 1:30 p.m.? Okay, so here, see, this is the minute hand of the clock. At 12 noon, where does it point? It points towards north. Okay, I'll just draw these directions again. North, south, east, west. So at 12 noon, where does it usually point towards? It points towards north. Okay, but here in a special case we are saying that it points towards northeast. Where is northeast? So basically, okay, I'll just show the figure under cardinal directions again. So you see these other four spikes which seem big but not as big as these four spikes. These four spikes mention northeast, southeast, southwest and northwest. Okay, so this is called northeast, basically between north and east. Southeast is between south and east, southwest is between south and west, northwest is between north and west. Okay, so these are the four these are the other four, like these are called subdirections. Okay, these are called, let's just write it here, subdirections. Okay, so right, moving on. So here, when you say northeast, basically, instead of the clock being this of this kind, the clock is somewhere like this at 12 noon. So this is north and this is east. Okay, it's northeast. In which direction does its hour hand point? So now what we need to look at is in which direction the hour hand points at 1:30 p.m. So at 1:30 p.m. the hour hand will be pointing towards 1, right? Usually that is what happens. Okay, the hour hand will be pointing towards 1. But here what we have is 12 is northeast. So 1 will be somewhere here. So hour hand will be here. Now this also looks like northeast to us, but you do not have northeast as an option. So you need to decide between north, south, east and west. Between these, which is it likely to be? It's likely to be east, right? Why? Because see, here this is 12 noon. You need to go a bit to the right to get 1, right? Because 1, 2, 3. So 1 is to the right. Now here, if you move to the right, you're basically, it's like this. So when you move to the right, you're moving towards E, right? Left is towards N. N is not. E is right. E is east, sorry. So when you move like this, you're basically moving towards east. And so the answer here is east. Okay, I hope that's clear for you guys. So this is what we have under direction sense test under the topic angle of movement. Okay, so just, you know, at 12 noon, this is how it looks. When you move, it moves a bit to the right. So you take this like this because you said that 12 noon has to be northeast. So this will be east. Okay, moving on now, the last concept that you need under direction sense test is this concept of shadow. Concept of shadow. So basically the thing is that when the sun rises, the shadow of any object falls in the west. So basically when the sun rises from the east, the shadow falls in the west. When the sun sets, sun rises in the east, right? So shadow falls in the west. Sun sets in the west, so shadow falls in the east. Basically the shadow falls opposite to the direction of that the shadow falls opposite to where the sun is. So see, if the sun is here, the shadow will be here. Okay, like you can see here. So here the sun is in this position, the shadow is at the opposite. Here, if the sun is here, basically if the sun is in front of you, your shadow will be behind you. If the sun is in the like this direction, your shadow will be in this direction. Okay, so because I mean, just think of what a shadow is. So shadow is basically like, I'll try to use my flashlight for this. Okay, so shadow basically what it is okay, you won't be able to see the shadow obviously. I mean, my shadow is visible here, but essentially what a shadow is that the light that is coming is blocked. Okay, so if this object is not there, there will be light here, but because of this object here, this light that is here is blocked, right? So you will not see light, you will see darkness instead, and the other area will be light. So basically that's what happens here. So see, for example, here, sunlight usually reaches everywhere, but because of this tree acts as an obstacle. Because of the presence of the tree, you are not able to get sunlight here, so the shadow forms. So the shadow will form the opposite, right? Because here, if the sun is coming from here, the sun, if this object is not here, and say the sun is here, sun tries to hit the ground like this, but because this object is here, sun is not able to hit the ground, so it stays here, and so this one's shadow will be like this. Basically it's just the opposite. So if the sun is in the east, the shadow will be in the west. If the sun is in the west, the shadow will be in the east. That's all there is. So when it rises, the shadow will be in the west. Why? Because the sun rises in the east. When it sets, the shadow is in the east. Why? Because the sun sets in the west. Okay, so that's all you have under the concept of shadow. um, we'll do questions in detail under all of these in an example class. We have an example class with lots of questions, so I've like sort of kept that for the example class. Like I'll just show you like a rough idea of the kind of questions we have. We have a lot of questions, right? So we'll do these in the example class. As part of theory, this is all that you need. Okay, so right, just have these in mind. The main cardinal directions. So these are just things, some things that you will need to know. What are the main cardinal directions? Also learn these sub directions: northeast, northwest, southeast, southwest. Okay, and then also learn what this is. Basically the shortest distance, the Pythagoras theorem. Okay, Pythagoras theorem, why do you use it? It is to find the shortest distance between the 2 points, and how you can use the Pythagoras theorem for that purpose. Okay, the shortest distance formula, just know that, and then also learn this. Okay, so some questions that we did, how to find this distance, how to find the square root, concepts like that. Also just take a rough look at this question and just think of what all we did in this question. This question is sort of an important one. Okay, okay, moving on. Angle of movement, and this is also another thing that we have under direction sense test. Basically clockwise and the anti-clockwise movements, what it is. So I'll just explain to you again. Clockwise is basically, you just think of how a clock moves. Okay, so I'll insert, because I'm bad at drawing shapes, I will insert a clock. I'll just insert it above this. Okay, right, so here, so basically if you have, okay, maybe we have a good figure here, I don't want to disturb this, let's move this here. Okay, so basically if you have 12, 3, 6, 9. How does the clock move? Essentially like this. Clock moves in this direction, right? Because if it is 12, when it becomes 1, it goes like this. This is how clock moves, right? You would have seen a clock moving. It does not move. After this, the minute hand does not move here, right? The minute hand moves here. So this is the clockwise direction. The direction in which a clock moves is the clockwise direction, and the opposite direction is the anti-clockwise direction. Another way of looking at it, as I said, is just think of how you would open or close a bottle. So basically, if you have a bottle with you, just try it now itself. Take a bottle, try closing this bottle. When you close, the direction in which you move is the clockwise direction. When you open the direction, just try using a bottle and you will get to know it clearly. When you open, the direction in which you open is the anti-clockwise direction. Okay, so that's what we learned under the angle of movement, and then we did one question, and then we had this concept of shadow, which again is a very interesting and fun concept. Basically just that, it's at the opposite direction. So whatever you have, it will be at the opposite. Okay, I'm sorry. I'll just erase this. The opposite direction. And why does this happen is also what I explained to you. Basically, shadow is basically what? See, just think of it. Sunlight is something that you have everywhere. Shadow is what happens when something acts as a barrier to the sunlight. So if the sunlight is coming from here and there is a barrier here, the sunlight will not be able to reach this spot. Okay, just think that this is the floor. Just think that this is the floor and this is your, okay, yeah, this can be the floor and this can be your object. Sunlight is coming from here. If this object wasn't here, the sunlight would have fallen like this. Now because this object is here, it doesn't go anywhere after this. It just falls on this object. So now because it falls directly here, what happens is here there is darkness, because for there to be light, the sunlight has to pass through, right? Because the sunlight is not able to pass through, here there is darkness. So basically, if the sunlight is in this direction, the darkness is what we call shadow, right? So if the sunlight is in this direction, the shadow is in this direction. So if the sun rises in the east, so the shadow will be in the opposite direction, that is the west. When the sun sets in the west, so the shadow will be in the opposite direction, that is the east. That was the concept of shadow. So that's all you have under direction sense test. Then we have a lot of questions that we will discuss in the example class. It is a fairly, I mean, some people find it a difficult topic, which is why I thought, questions we can mainly have in the example class instead of having now. But yeah, so that's it. That's all that there is for direction sense test.